What if you were dropped onto another planet just to watch the sunset? You might think it's simple. The sun goes down, the sky gets dark. But the universe doesn't play by such boring rules. Out there, sunsets can get strange. On some worlds, the sun sinks halfway below the horizon, then suddenly reverses direction, rising back up before setting again a second time. On others, the sky burns deep red during the day, only to shift into an eerie blue as evening falls. And sometimes, what you're watching isn't even a sun. It could be a pulsar flashing in the distance, or light bending around a black hole. In this scenario, you're no longer bound by physics. You'll travel across the solar system and beyond to witness the most unbelievable sunsets imaginable. Right now, you're standing on Mercury. There's almost no atmosphere here, so even in broad daylight, the sky remains pitch black, filled with distant stars. You'd expect a normal sunset in a place like this, but Mercury has something far more unsettling planned. Near its perihelion, in high-latitude regions, you watch the sun slowly descend toward the horizon. Then it stops, completely still, and just when you think it's over, it rises again. Only after that does it finally set. Meaning on Mercury, you can watch the sunset happen twice in a single day. Seeing two sunsets isn't a glitch in your vision. It happens because Mercury's rotation and orbit are bizarrely synchronized. It races around the sun incredibly fast, and its orbit is highly elliptical. When it gets close to the sun, its orbital speed briefly overtakes the motion caused by its own rotation, and for a moment, the sun appears to reverse direction in the sky. So instead of a smooth, predictable sunset, you get a stop, a rewind, and then a second descent. Mercury alone already twists the idea of a sunset beyond recognition. But this is just the beginning. Now you arrive on Venus, and everything shifts to another extreme. The atmosphere here is unbelievably thick. The surface pressure is about 93 times that of Earth. You won't see a clear solar disk at all. Instead, the sky is a suffocating yellow haze, dense, heavy, almost oppressive, and the sunset painfully slow. Venus rotates in the opposite direction compared to most planets in the solar system. Here, the sun rises in the west and sets in the east. But even stranger, its rotation is incredibly slow. One full solar day on Venus lasts about 116 Earth days. That means watching a single sunset here isn't a matter of minutes. It takes days, long, dragging days, as the dim light slowly fades through that thick, choking sky. The sky here won't shift from blue to orange like it does on Earth. There's no warm glow, no gentle fade into a starry night. Instead, it starts as a dull yellow, slowly compressing into a deep, suffocating red, until everything is swallowed by a darkness so thick you can't even see the stars. You've crossed Mercury and Venus. Now you step onto Mars. During the day, Mars looks red, but its most famous moment comes at sunset, a hint of blue. The reason lies in its thin atmosphere, filled with fine dust particles rich in iron oxide. In daylight, that dust scatters light in a way that paints the entire world red. But as the sun sinks toward the horizon, something unexpected happens. Blue light begins to scatter forward more efficiently, streaming directly toward your eyes. So on Mars, the red desert glows under a soft, eerie blue halo at dusk. At this point, you start to realize, even within the same solar system, every world rewrites the meaning of a sunset using its own laws of physics. And now, after witnessing the inner planets, you're ready to push further, toward the giants. Your next destination, Jupiter, a planet so massive, it doesn't even have a true solid surface to stand on. You can't stand on Jupiter itself. There's no solid ground, only endless layers of turbulent clouds. So you watch the sunset from the cloud tops. And here, the most striking thing isn't the color, it's the speed. Jupiter completes one rotation in just 9 hours and 55 minutes. That means within a single Earth day, the sun can rise and set more than twice. On Earth, sunsets feel like a slow dimming of the lights. On Jupiter, it's like someone hit fast forward, but even that starts to feel normal. So you turn your attention to Jupiter's moons. You land on Io, one of the most volcanically active worlds in the entire solar system. Its atmosphere is extremely thin, so even during the day, the sky looks almost black. But the real spectacle isn't the sun setting on its own, it's Jupiter. That massive gas giant slowly drifts across the sky and begins to block the sun, not for a moment, For hours, you watch as the sun is swallowed whole, a colossal eclipse that can last nearly 2 hours. This isn't just a sunset anymore, it's a cosmic-scale shadow. Then, you leap to Europa, a frozen moon of ice, and even in broad daylight, it still feels like night. But the strangest part of Europa comes after the sun is gone, because when the sky goes dark, the ground may begin to glow. Jupiter's surroundings are flooded with intense radiation. High-energy particles constantly bombard the icy surface, causing it to release a faint, ghostly light. So here, night doesn't just fall from above, it rises from beneath your feet. Then you move on to Ganymede. It's enormous, larger even than Mercury, and it's the only moon in the solar system with its own intrinsic magnetic field. At dusk, charged particles from Jupiter spiral along these magnetic khut, slamming into its thin atmosphere. They ignite auroras, but not the kind you'd easily see. Most of the energy lies in the ultraviolet range, so to your eyes, it's just a faint, almost invisible shimmer, a whisper of light flickering in the darkness. After exploring Jupiter's realm, you decide to go even farther. Now, you arrive at Titan. Here, the sky is permanently wrapped in a thick orange-brown haze, and the lakes on the surface, they aren't water. They're made of liquid methane and ethane, so when the sun begins to set, you don't see a clear horizon fading into darkness. Instead, the entire world slowly compresses from a hazy orange into a deeper, heavier brown, as if the light itself is being drowned. Then, you look up. Saturn's massive silhouette hangs in the sky, a view that feels both beautiful and overwhelming. As for Saturn itself, like Jupiter, there's no solid ground to stand on. But if you hover above the cloud tops at dusk, the real spectacle isn't the sun, it's the rings. During the day, countless icy particles scatter sunlight, turning the rings into a brilliant, glowing band. But as evening approaches, something incredible begins to happen. Saturn's own shadow slowly creeps across the rings, segment by segment, dimming that vast arc of light piece by piece. This isn't just a sunset, it's the most iconic structure in the solar system, switching off in front of your eyes. A ritual you won't find anywhere else. For your next stop, though, I wouldn't recommend Uranus, because it takes the idea of waiting for sunset to an absurd extreme. With its extreme axial tilt, it's almost rolling around the sun on its side. So if you stood at the wrong place, you might have to wait 42 years just to witness a single sunset. But when it finally happens, the sky won't turn pink like on Earth. Methane in the atmosphere absorbs red light, so instead, the world fades from a bright cyan into a deeper and deeper blue-green, a slow, quiet descent into cold color. After enduring those 42 long years, you finally arrive at Neptune. Out here, there's nothing left but cold and distance. Sunlight is incredibly weak, only about 1/900th of what Earth receives, so sunset doesn't feel dramatic. It feels like a slow shutdown. The sky fades from deep blue straight into absolute black. No warmth, no glow, just silence. But you're not here for something ordinary, so you push farther. You leap to Pluto, and suddenly the mood shifts again. Even though the sun is dimmer than ever, the sky isn't necessarily dead black. Instead, it can glow with a deep, fractured blue, subtle, fragile, almost unreal. And above you, Charon, its largest moon, hangs motionless in the sky. Locked in a permanent dance with Pluto, it never rises or sets. It simply watches as the light slowly fades away. With time still left, you decide to go beyond the solar system. And that's when everything changes. Because inside the solar system, no matter how strange the sunset gets, you're still watching the sun. But out here, even that role begins to disappear. You take a step forward and land on Kepler 452b, often called a super-Earth, or even Earth 2.0. But what kind of sunset awaits you here? It orbits a star similar to our sun, but older and slightly brighter. So the sunsets there feel familiar, just a bit more intense, more radiant than on Earth. But that's not enough for you. You want the limits. So you push further to more extreme worlds. On planets like Kepler 444c, the star itself isn't especially large, but the orbit is so tight it looms enormous in the sky, a blazing giant overhead. And still, it's not enough. You're no longer satisfied with ordinary stars. You want something completely different, so you seek out planets that don't orbit stars at all. And when you arrive at PSRB 1257+12c, everything changes. There is no familiar sun waiting for you. Instead, a pulsar. Its entire body is only about 20 kilometers across. Yet it's a neutron star, so dense it defies imagination, and it spins insanely fast. 161 rotations every second. Like a cosmic lighthouse, it sweeps beams of radiation across space again and again and again. So if you stand on that planet, watching what you'd call a sunset, you're not looking at a steady, glowing star. You're facing something else entirely. A flicker, a pulse, a beam that appears, disappears, returns, over and over. This isn't a sunset anymore. It's a strobe of cosmic light, blinking you in and out of darkness. What you see is no longer a steady light source, but a violently flickering point, sweeping, flashing, pulsing across the sky. It's not a sunset anymore. It feels like the universe itself is strobing in front of your eyes. But even a pulsar isn't your final stop. You move on toward a white dwarf system. Beneath your feet is WD 1145 plus 017b. It can barely still be called a planet because it's being torn apart, slowly evaporated and shredded by the white dwarf it orbits. The star itself is only about the size of Earth, yet it holds a mass comparable to the sun, and the light it emits, a harsh, piercing blue-white glare. So every sunset here feels anything but peaceful. It's not romantic. It's a world falling apart, skimming past destruction again and again. This might be the end for that planet, but not for your journey, because the most extreme sunset of all may exist around a black hole. So you go there. We haven't directly confirmed such planets yet, but in theory, stable orbits are possible. Now imagine you're standing on one of them. What you're facing now is no longer a sunset in any familiar sense. What you see might be a mass of glowing matter, twisted and stretched by extreme gravity. Stars themselves appear warped, their light bent into impossible shapes. Behind it all, a vast ring of light forms around a dark abyss, an accretion disk circling the void. Even the sky is no longer stable. Space-time itself is distorted, like a cosmic lens, bending everything you see. Near supermassive black holes like Holmberg 15A, with a mass of about 22 billion suns, or the even more extreme TON 618, approaching 66 billion solar masses. If planets could orbit nearby, and in theory they might, then the spectacle of sunset wouldn't even be the point anymore, because what you'd witness is not the sun disappearing, it's space-time itself being twisted right in front of your eyes. And in that moment, you might remember something simple, a sunset on Earth. You'd realize, yes, the universe holds stranger skies, more extreme light, more dangerous beauty, but the number of places where life can quietly stand and calmly watch a sunset unfold is incredibly small. Compared to the wild, distorted evenings of the cosmos, that ordinary sunset was never ordinary at all. Earth's sunset may not be the most extreme in the universe, but it's gentle enough to matter, and that kind of softness is rare. Drop a photo in the comments of your favorite sunset. I'm Saud. See you in the next universe.